Okay, so we're going to look at several different types of quadrilaterals and talk about the formulas for area, but also find the perimeter as well. And remember, when we're working with perimeter, we're just finding the distance around the figure. So you've got to find those outside pieces. Doesn't mean you'll need all those pieces for the area formula, but you will need them for the perimeter. So let's start with parallelograms. We know the formula for a parallelogram is just base times height. You cannot use a slanted side. You have to use the true height, which is perpendicular to the base. So in order to do this, you need the base and the height for the area. But for the perimeter, you would need the outside pieces. Okay, so let's find all those pieces first. So we know that opposite sides in a parallel are congruent. So if the right side is 8, the left side is 8. Same thing with the 10. If the bottom is 10, the top is 10. So right there, perimeter is easy. We're ready to go for that here in a minute. But we've got to concentrate on finding the height. Well, I see that 45, 45 right triangle. And so let's go ahead and set up a little T-chart for it. We know that 8 is across from the right angle, so we know that it goes here. And so that's not what it's supposed to look like, so that's when we set up our equation and divide by the square root of 2, which ends up multiplying by the square root of 2, and so we get 8 square root of 2 over 2, which does give me 4 square root of 2. We saw this when you were working with your regular polygons. Okay, so that tells me that this right here is 4 square root of 2. I don't need this bottom piece here because I already know it's part of the 10, so it's not necessary to put on your chart. But now we have everything we need to do the formulas. So the formula for area is base times height. Well, our base is 10. Our height is 4 square root of 2. So think these are your like terms, so combine those together. You get 40 and put that square root of 2 at the end of it. And it doesn't give us what unit we're working with, so we'll just say units squared. We, for perimeter, can add up the outside pieces, so we have 2 10s and we have 2 8s. So 10 and 10 gives me 20, 2 8s gives me 16, add those together and that gives me 36, and there's our perimeter. So when you're working with parallelograms, remember for area, you need that height, which is inside the figure. You could do one that's outside, but it's usually the one that's inside where you have a special triangle to work with. Okay, so now let's work with rectangles. Rectangles are basically the same thing as a parallelogram in terms of formulas. Outside edges for perimeter, base times height. But because it's a rectangle, remember these angles are right angles, so your height would be right here. So we have our base and height, we're ready to go. We know that in a rectangle, opposite sides are congruent. So we know that. So now perimeter, base times height. So let's talk about how to multiply those two radicals. So remember, outside times outside, inside times inside, but we know the square root of 4 is really 2. So this is really saying 20 times 2, which does give me 40. And did it give us a unit? Nope, so we'll just say unit squared. Perimeter, we're going to add our outside, so let's make a note that we're doing 2 5 square roots of 2 plus 2 4 square roots of 2. And so that gives me 10 square root of 2 plus 8 square root of 2. They both have the square root of 2, so I can combine my outside numbers here. Those are like terms, and that would give me 18 square root of 2. Don't forget your radicals. And that's the parallelogram and rectangle. So base times height, just make sure you find your true height. Remember, base and height have to form a right angle, so look for those right angles. All right, our next one is the rhombus. And so the formula for a rhombus is up there at the top. Those D's stand for diagonal. So diagonal 1 times diagonal 2, and then cut that in half. So we know that this diagonal has a length of 48. So I'm going to make a note to myself. Diagonal 1 is 48. Diagonal 2 we don't have yet right here in blue. So we've got to find that. But we do know properties of rhombus. Remember those quadrilateral properties that we spent time on in Unit 7. We know that the diagonals are perpendicular. So we do have right triangles. So if I'm looking, let's say for this side here, I can do Pythagorean theorem to help me find that piece. And then it'll be the same on both sides because your diagonals have been bisected. So we could set up and say that this is our, let's say A, and this is our C. So we would say 24 squared plus B squared equals 25 squared. We would subtract the 24 squared. And so B squared equals 49. And if we square root that, B would equal 7. And so that tells me that this is 7 and this is 7, which means diagonal 2 would be 14. So now I have everything I need ready to go. So for perimeter, we know all the sides are the same because it's a rhombus. So we can say 4 times 25, which does give us 100. For area, we're going to multiply diagonal times diagonal. So 48 times 14 and cut that in half. So plug that in, 48 times 14 divided by 2, which would give you 336. Okay, rhombus, remember you need your diagonals to find the area. And more than likely you're going to have to use Pythagorean theorem to find one of those missing pieces. All right, next is the trapezoid. There's your formula. You have two different options here. You're not going to really work with the median formula much, but I wanted to go ahead and provide it for you just in case you saw something like that. Median would be in the middle where it connects the midpoints on either leg. For the most part, we're going to use this formula here. So let's talk about what those mean. The B stands for base, and that H stands for height. So you're going to add your two bases together first. Remember, bases are the ones that are parallel. And then we multiply it by the height and cut it in half. So let's look at this first example. We need a couple of things. We need base 1, base 2, and our height to find the area. We'll need our outside pieces to find the perimeter. And so let's look and see what we have. Well, we know that this is based off of a rectangle and a triangle put together with this trapezoid. So if that side's 4, then this opposite side has to be 4. And then we would also know once we found this side, we would also have that one. So let's look at this little right triangle here. We know it's a 45-45, so we can set up our tic-tac-toe. We can see that 3 square root of 2 is across from the 90, making this really easy. So this x is 3 and the other x is 3, which means I can stick a 3 here and a 3 here. So now we know that our full base is going to be 7. So our top base is 4, bottom base is 7, and our height is 3. The only other thing we need to add is the 3 on the left side so that we can find the perimeter. Because remember, the perimeter is all the outside pieces. So when you go to do that, we're not going to include this one here that I just marked out. That's just for area because it's inside the figure. Okay, here we go. Area, we're going to say base 1 plus base 2 times the height, cut in half. So 4 plus 7 gives me 11. 11 times 3 is 33 divided by 2. That doesn't divide evenly, so we can just leave it as a fraction or the decimal. It doesn't matter to me. And still no units, so unit squared. And now let's do our perimeter. So again, we have to add our outside pieces. So I'm going to change my colors here. So top is 4, the left is 3, the bottom is 7, and the right side is 3 square root of 2. Well, not all of those are like terms. These 3 are like terms, which gives me 14. But I can't combine it with that 3 square root of 2. And I don't want a decimal. I want you to keep everything exact. So we would just say 14 plus 3 square root of 2 units. And that's okay to leave your answer like that. That is more exact than trying to round a decimal. Okay, so let's look at the next one. So we've got some things that we have to figure out. Well, I know opposite sides are congruent here. So this piece right here has to be 22. I don't know if it's isosceles or not, so I can't assume the other side is 15.65. We'll have to find that. Well, actually we don't, because we don't need the perimeter, we just need area here. So let's think about what we have and what we need. Base 1, the top base is 22. Base 2, the bottom base is 50, but we're missing a height. So we have to think about that. So we need to figure out what these little pieces here with the x's are. Well, I know that if I put them all together, x plus 22 plus 3x equals 50. And so if I combine my like terms, 4x plus 22 equals 50, move the 22 over, 4x equals 28, and x would equal 7. So that means this is 7, and 7 times 3 would be 21. And if we added those together, we'd be back at 50. But that helps me because now I can use the 7 and the 15.65 with Pythagorean theorem to find my height. So here we go. I'm going to change colors so you guys can follow along. So we're going to say, to get the height, we're going to say 7 squared plus b squared equals our hypotenuse, 15.65 squared. Move the 7 squared over. Remember, you have to square it before you subtract. B squared is going to equal, actually, let's just do it in our calculator and square root it. So let's just find b. And that's going to equal 13.997. So again, I subtracted, no, I squared, I subtracted, then I square rooted. So that gives me our height. And now I'm ready to plug into the formula. So remember, the formula is add your two bases together, times it by the height, and divide by 2. And if we plug all that in, we would get 503.892 units squared. So a lot of right triangles, so it's either going to be a 45-45, a 30-60, or you're going to have to use Pythagorean theorem. Always look for Pythagorean theorem first, because that's the one where you will use if you know 2 of the 3 sides. All right, last quadrilateral here would be the kite, and the formula is just like it is with the rhombus, so diagonal times diagonal divided by 2. And let's think about some things we know about kites. Well, we know that these 2 sides are the same, so both of those would be 15. We know that these 2 sides are the same if it's a kite, so this is 41. So now we have everything we need for the perimeter. That's ready to go. We also know that this diagonal has been bisected, so both of those are 9. So we have one diagonal would be 18, but we need to find our other diagonal. So we're going to have to use Pythagorean theorem to find these pieces, and we're going to have to do it twice. So we're going to have to do one with the 9 and the 15, and remember that's a right angle, so 15 would be your C. So 9 squared plus b squared equals 15 squared. Subtract the 9 squared over, square root, and b would equal 12. And so that 12 is going to go right here. Draw an arrow so you remember where I got that information from. And now we're going to do the same thing with the 9 and the 41. 9 squared plus b squared equals 41 squared. Subtract the 9 squared over, square root, and b would equal 40. Now we know that our second diagonal, if we add the 12 and the 40 together, that would give me 52. And so now we're ready to go. Area, diagonal times diagonal, so 18 times 52. Cut that in half, and that would give you 468. And this time they gave us a unit, so feet squared. Perimeter, we would add our outside edges, so we have 2 15s and we have 2 41s. So we can say 30 plus 82, and that's going to give us 112 feet. So before you think about finding any of the answers with area and perimeter, find your missing pieces first. Look for those right triangles, look where you can use Pythagorean theorem to help yourself, and then once you have all those missing pieces, then find the area, then find the perimeter.